Hi, welcome to this tutorial on how to use this Colab version on tracing motion for MMD. This is a version 2 update from the author, and the motion that I will use for this demo is a dance from a latest dance motion that is captured in this video. It is the name of the program, MMD Autotrace, and 2, the Ocean 2, with the release 5.04. So from this program, the first thing is that just before we execute anything, you require to go into your Google Drive. I assume you have a Google Drive. If not, you have to create this account. Normally, when you Google Drive, essentially this is your main root directory, and you have to create this subfolder called AutoTrace. In the screen that you see, I have already done this particular motion tracking or tracing, sorry, and it's called Dreams Come True. All right, and if you've done it correctly, you will create a folder by the program automatically, and it will have the date and time when you created that motion file folder. Uh, there would be two other files that require to be also uploaded into this auto trace that you need to extract, and it will be part of the instruction. Just a quick view, the two file required is one called the expose data zip file, and the other one is called the model simplex version 1.1 zip file. So, if you want to do a brand new tracing, you will have to upload your file, which is in this case, you just do a right click and upload the file. So this is the file that you'll be using. The file name is very long. I think for ease of testing and making sure that you remember, I just call it input. All right, so this will be the input video we'll be using for this tracing. So you need to open up this page in Colab, just based on the link that we provided, and you will see this page. Um, so once you have created the subfolder in your drive, you can also do the first part of the work, which is called the advanced preparation. But here they summarize for you in this program itself. The good thing about Colab is that the program have a clear explanation by the author how to execute the program, right? There are basically 6 steps or 6 set of steps that need to be executed for each time you run Colab. But before this 6 step can be done, you need to do the advanced preparation, which is only done once. So I'm going to go to the advanced preparation. And the advanced preparation, there are very clear instruction on how you have to go into a particular web page and then download this file that I just showed you earlier on. And you go to all this instruction, and then you get the expose data. I just repeat again, this expose data you need to obtain from that instruction and then upload into this auto trace folder. So that's one file. The other file that you will need to run is this instruction here that will allow you to download the simplex model file. And again, after you download it, I'll have to upload into your own auto trace folder. So this is the second one, first one, second one. Once you have these two data file, which is done only one time, you can reuse it for all future motion tracking. So now we have to execute the 6 steps that is required for every new motion video that you track. Before you execute your data, just double check that you have already loaded your video file, which in my case, I uploaded it and renamed it called input.mp4. You can name it any names. It doesn't have to be this name, but I just use this name for this demo. Now, the instruction for running the program is pretty straightforward because it's already given in the program itself with clear instruction. So here in step one, you just have to run. See the little button here. There's little play button blank with a little icon to play. If you just have to click on that to execute every step, all right? So I'm going to just run through the step so that you have an idea how it looks like when you execute on your own. Um, right? You may have a security or anything, but run anyway, right? Just one thing before I do that, I just want to remind you that when you come to this site, you may have a lot of Japanese words appearing because it was written a lot in a mix of English and Japanese. So it would be good to have your own translator. In my case, I have a extension added into my Chrome browser, and I have a Google Translate added into my Chrome. So you just have to click onto this and reload it to make sure that it is in English because I think this tutorial is for people who understand only English basically. So once you have done the translation, you go to this site. So I'm going to start again step one, and now I'm going to execute the first play button in step 1-1 in this case, cooperation with Google Drive, and always just run anyway, all right, because it looks like. So the first thing is that you need you to connect to the Google Drive, uh, select the name that you have your Google Drive set up and click continue. Okay, so you can see now there is an output with all these lists of files showing that it has file that in your current folder and it's okay. So that part of cooperation is confirmed okay. So you just scroll down and look for the next button. The next button say that you have to cooperate with the Google SDK too. So in other words, you need to use Google as system development kit to run this program. So you need to again see the play button here. You have to click on that. So now you're basically trying to uh, get authorization to use the Google SDK. Now you notice that there's a link that come out here. This link you need to click on it in order for you get your authorized code for this particular run. So if I click on that, it will prompt up to a new page. And again, you have to log in. If you don't have an account, you can always create an account with the Google Cloud SDK. And for me, I already done it. And now it will generate authorization code for you to use Google SDK. Click on this little icon to copy the code and go back to your program, which is on a different tab in my case, uh, and click onto the box and Control V to paste it. Press Enter. You see a message says that the integration file with Google SDK was successful. So this step is successfully done. Next step is to check that the learning data file is placed in your drive. It's always good to run it, even though you know you have already uploaded it. It will now try to bring in this data into your environment. So that's done for the first learning file. The second learning file is a simplex file. Again, there's a button here. You have to execute it. Okay, this shows that it's successfully run, so you have placed this particular file in your environment as well. And now we're going to step two, which is basically to change your runtime type to GPU. The intention of using GPU is that it process faster for your this auto trace. And again, there's a little play button. You just click on that and check. You just heard a sound. The sound shows that you have successfully run this setup. All right. Just in case you don't know how to do the setup, you can do it now and run that again later on. Click on runtime, change runtime type, select GPU. The default is always none, all right? Uh, in this case, you need a GPU and you have to click save if you have not done it before. But it's a one-time effort. You have to make sure that your runtime is set with GPU to ensure that your extraction and auto tracing is faster. Otherwise, it's very slow. Do the code preparation. So now you have the learning data in place. You have a cooperation with Google Drive. You have a cooperation with the Google SDK too. So step three is to prepare the code. So again, there's a little play button. Just run that before we do step four. Okay, so this is a successful code construction building, and the time is, you can see on the screen, is 30 minutes and 41 seconds. And again, in step 4, you have the little play button for you to run the code. So now we are trying to place the data for the next step. So again, we click here, and now we're going to leave it running as usual so that you can also see. So this step is completed now. It takes about 2 minutes and 11 seconds, as you can see on the screen bottom. Again, be sure that you can see this okay, the placement is done successfully. Now the next step is to input the video file. So anyway, I have named the file input.mp4 for my video, and therefore give this to confirm that the video file has been placed, and it's very quick. It shows that, oops, uh, it shows there's an error. Let me see what happened here. Uh, Now it's okay. I don't know why, but I done it in the past. Input file is okay, but anyway, just rename the file and it seems okay. It accepted the file name dreams.mp4. So now it's step 6. Now this is the longest part of the whole program, right? Uh, and you normally get this message. This is almost full, but don't worry about it. If your video, as far as I tested, up to 3 minutes video motion, it has no problem. Eh, Uh, you can do, as they say, ignore this, all right? Um, Even if you go into Colab Professional, which you need to subscribe and pay a small amount, it doesn't really help a lot. But so far, my experience is that for any 3-minute motion file, this program works fine. All right. But just be aware, it will prompt up this message and just click ignore and you will proceed. All right. So now we do from step A. Now there's nothing created in your drive. I want to show you again at this moment, there's no folder created for this video. If it's successful, you will see the word dreams folder being created, just like what I've done earlier on, dreams come true. That was done in a different session, but in your new video, in my case, dreams, I should see a folder name, right? But let's execute step 6 and 6B, you will see that. So this step will take quite a bit of time, so I'm gonna let it run as usual. Okay, now the step 6A is done. It asks you to check the result. Let me see. So I'm going to click this. So we can play the dance. Up here, in this case, there's only one dancer, so there's really not much we need to do. Most of the time, it looks good. You can download this file if you wanted to. If you want to do that, you need to click this button. Okay, it has copied the BB box into your folder. So now you can go into your folder and take a look. Uh, okay, Dreams MP4 folder has been created, and you have that video that we just saw, BB box, and you can download it and I'll take a look at it again. Otherwise, we can skip to the next step. So what you have seen the video here that on this program is just a recap. It's now called bbox.mp4 and you have copied over to your drive. Before that, it was in the system drive. This is just a pause. Sorry, my apology. We don't really need this to run this step. This is only to give you a pause so that you can focus on the next step. 6C. This is only required if you have more than one person doing tracking, and you have to make sure that they are in the correct order in terms of which frame and which index belong to the same person. All right, so you have to do the ordering. So, but for the purpose of this tutorial, we only have a one person motion tracking. So this, okay, let's execute 6C. Execute now. You can now see that video just to prove that it is correctly set up. Again, this is a one person motion. There's not much to check. It's always accurate. Again, if you want to have a copy of this video, you can click this next button. But if you do not want it, there's no need to do it. But I'll just do it for completeness. Uh, Let me see what happened. Okay. There seems to be an error, but I don't really need it. The trick here is that if you really want it and you don't get it, you can go into the system drive. Uh, yeah, this is the file. So I'll repeat again, if you are doing multiple person, this video is important for you to check that you have done it correctly in terms of ordering. I'll repeat again, maybe just to scroll back. If you have done this part correctly or incorrectly, this can be shown in the video here with multiple person. that it should have only one index for one person after correction of the dance. So this video, I don't know why, but there seems to be a bug here in this step. Um, but because for it's a one person video, I don't really need it. But if you really need this video and want to keep a copy of it, you can go into the system file, which is not in your current Google Drive folder. So you can download here into your local PC and upload it back into the Google Drive if you wanted to. If not, just download it for your own keeping. All right. Otherwise, if you think it's wrong, uh, after viewing this BB box, you can go back to your step 6 C and redo your ordering and execute again 6C, 6D, and then 6E and view one more time. All right. So 6C to 6E is really about multiple person, and you want to make sure that the right set of ordered sequence is correctly done. Finally, the most important part of the whole tracing is creating the motion file, which in this case is for MMD. There's an option whether you want to trace the hand and the facial as motion. I haven't done the face motion. I don't think it's that accurate if I'm not wrong. I did it once in the past, but again, I haven't really done much on that. As for the hand motion, my experience is that it is 30 to 40% accurate most of the time if the hand don't move too much. If the hand move a little bit, it should be quite okay to use this. But the only thing I don't like about using the motion hand is that when I choose this option, the execution time is almost double or more because this step is pretty long. If it's a video, like in a 3 minute video, I've done it like 1 hour processing. But in this example, the video I'm using is about less than 2 minutes. So let me run it and see how long it takes. It execute on its own. So this is I want to repeat again. This is the part that create the VMD file. Uh, So this complete the motion output. It takes about 6 minutes or 5 minutes, 16 seconds in this case. And dreams folder, you should be able to see all the motion file. There are 5. I find that this motion can be used in most of the MMD models. Okay, the next part is that we have successfully created the motion file and I have downloaded it from the Google Drive just to show you this was the one that we created under the Dreams folder that was created by the program. I downloaded it and I put into my own tutorial folder for this tutorial. And you can start using it in your motion. But I want to demonstrate to you the results that I already done beforehand. So just to see what it looks like. Okay. Um, so I have extracted the original motion in this case into this MMD and I just run it and just so you can have a look what it looks like. Notice that every time when you run a motion file that you extracted from the AutoTrace Colab program, there's always seems to be a sensitivity of the Y and X direction motion. And I normally use one of the animation smoothing to animate it and make it scale it down So again, just to show you what it looks like, this is the same motion, and I just want to show you. If you look at it, they're doing the same motion, except that this particular character, the same motion file, all I did was just to average out the Y and the X motion, which is based on the root bone, so that it doesn't go too much to the left or right, as well as I have applied um, IK into this motion. I repeat again, this original motion when you get the IK frame is not captured in terms of keyframing, but you can use one of the two provided by the author and convert it into IK frame so that the IK is included as part of the motion. So that is a step that you can do, but I'm not including in this tutorial. Another thing you can do is that you can adjust the motion even further by using pose. In Blender 3.0, we have a nice pose library concept, which you can capture key position of the pose. So let me run auto motion again. You can see that now this center girl have a much better motion in terms of it looks about more smoother. So that's three things I have to do. The one here on the left is the original motion. The one on the right is a motion where I converted into a IK frame and also scale down the X and Y positioning uh, so it looks a bit more stable. And and the center one is the one where I use the Blender pose library concept to capture key poses and join them up. So you can see that, there's a number of key poses frame that I captured manually. For a much more perfect solution, I go one more step further. Now notice that when you captured a motion file into MMD using the AutoTrace program, the timing is not exactly matching. So you need to scale the time slightly smaller to match the time. So the final result, I just want to show you what it looks like. I can assume is that this is the video that we just processed, and this is the final outcome of my Colab AutoTrace with poses captured and smoothed out a little bit, so you can see for yourself how good is the AutoTrace. Okay, so this MMD, I will remove the skeleton so that we have a good eye. All right, so this is the results of tracing motion using the Auto Colab and doing some level of smoothing in Blender and using Pose library to smoothen out further so that the dancing matches well from the original dancer to the MMD dancer. It's not 100% perfect, still can be improved further. Oops, it bombs. Let me try again. Blender does bomb every now and then when you do something fast or something strange. All right. So, like I said, this motion is being scaled to time it exactly as much as I could from an eye perspective that I saw. And I added a couple of more poses in between based on the video to smoothen out the dance step. All right, so this is the end of the tutorial for auto collab tracing of motion into a MMD character of version 2. And if there's any interest for people to learn how to do smoothing in Blender that I early on tried to illustrate, I perhaps can make another tutorial on that. But otherwise, this tutorial really focus on how to use Colab AutoTracer to create the initial footprint of the motion. Um, yeah, thank you. Bye-bye.
Hope you enjoy the video. Thank you for watching.